Hi everyone, welcome back to my putting simulator project. So today we're going to be working on keep caps. We're going to be working on walls and collisions. If I have time, you know, if this goes pretty quick, I'll start the language. To create these holes. Oh my gosh. I should just update it. That's not likely though. I don't know how long I want to spend today on this project. But otherwise, let's see what we can do. So we have main, we have a ball. We're going to need a wall, but the wall, I think, is just going to be a struct. And the reason why we need that is so that we can actually pass this wall into like a kind of like detect and collide with wall function that we're going to be putting a ball. So let's go ahead and do that. The file, it's going to be wall.rs. Okay, just to make sure I'm not losing my mind. Pub struct. Do I need it? Let's keep vec2 in there. Pub struct wall. Capital wall. What we have here is we have how do we want to define this, right? I guess we only need 2 points to define this wall. We need a top left and a bottom right point. Or, you know what, let's make a constant. I'm going to do this. Wall width. This is an F64, just to keep it consistent with everything else. And this is going to be equal to 3.0. Right? Let's make it a 4. Make it an even 2 for halfway. Okay. Pub struct wall. So what we need here is we need like a point A and a point B. And there's going to be vec2s. So let's see. Pub vec2. I'm sorry. A, I guess. And I think that's really all that we're going to need for right now. Yeah, that's what it looks like. It's pub. Okay. Impl wall. New self. That's what it looks like. Always got to refresh myself whenever we jump into these things. And what I'm going to pass into it is a vec2 and a vec2. Just 2 points, right? That's all I need there. We just do A, B. Okay, looks good. Probably because I'm not using it yet. Let's bring it in and make sure that it's actually real. These are probably going to look different when I actually pop these out into their own library. Lib? Into their own lib. outside of play. Figure 1 of 8 possible tokens. What? It's just like that, right? I need to do self. What was that? Okay, it's compiling. Now we have this, we have a wall. Let's what are we gonna do? I wanna make some walls. Okay. Let's walls equal new vec. Is that what that looks like? I think it's just vec. Oops. Gotta give it a type. Type must be known. Okay. Use crate. What's going on here? I gotta do this. Okay, that's looking good. I need to do walls, dot. What is this? Now it's time to pop out some docs. See what we're looking at. It's just a pen, right? Push. Append is extend. I'm just looking for push. I think it's supposed to be lowercase. Did I do capital? Stay doing capital. New, back to. Where do I want to start this? I want to kind of go around the hole. So for now, these might be looking kind of funky, looking a little weird. Let's just start out with one wall, and I want this to be a horizontal wall. I'm thinking now. That this might not work. So what I'm looking at, okay. I need to create a wall. And with this wall, can I define it with 2 points? I was thinking just my cat Nellie is going insane right now. She loves to scream. Very loud. She howls. I love her to death, but man, if there's 5 minutes where you're not paying attention to her, she lets you know. But okay. So I was just thinking one side is a point. Like I was just thinking I could do something like, if I could draw this out in text, it might be kind of weird. Right, and then I have like a dot here. and this is kind of the point that I define, and then we'll say, imagine this is like on the top of the line, right? Let's get rid of this. And imagine we have this here. Right, this was kind of my idea, how I can define these with 2 points. But I don't know if it's really doable. Because for one, how do I know what direction to move these? A wall should be a wall. It shouldn't have to be. I think I just need to define a top left and a bottom right. I guess let's look at. How does macroquad do it? That's kind of the important part. Let's look at their docs. Because if they can tell me how they do it, then it should be a lot easier for me to do it on mine. X, Y, width, height. Top left corner at X, Y. So you define a top left, and then you define a width and a height. So yeah. Finally. X, Y with height, and X, Y is top left. So I'm thinking what makes most sense for me to do. Defining 2 points. Now that makes sense. Especially if I'm only starting out with vertical and horizontal walls. This will make it a lot easier actually. Let's figure that out. So I have 2 points. And I'm gonna keep this idea actually. I think I'm gonna keep this idea like this. And then just within my wall, I could actually figure out what the other stuff, like what else is doing. So let's go length. That's just gonna be a float. What else do I need? Up top left. It's a vec2. Pub dimensions. That's also a vec2. So I don't need to keep these. I just need length. I just need top left, dimensions, and length. Let's rearrange these. Right. It's gonna be X, Y. It's gonna be width, height. Because that's how they keep them. X, Y, width, height. The color is always gonna be brown. It's the wall. It's going to be the wall of a mini put, of course. Walls are usually brown. I'll just keep them as brown. Maybe we'll add some new fun stuff later, but that's not what I'm expecting. Can I rename this? I should be able to rename this. I want to rename this. Instead of A, I could just do like side 1. whatever, I'll just call it A. A's fine. So what I need to actually figure out here is what my top left is. I'll call this top left. I'll call this bottom right. Neither of them really are the top left or the bottom right. See, like this, when I say this, I mean this could be the top left wall, or it could be the top wall, it could be the left wall. This meaning it could be the bottom wall, it could be the right wall. So, top left, I need to figure out if it's vertical or horizontal. So if it's vertical, let's match. Top left. Dot. How do I use these? Is it dot 0? Dot x and y. Okay. Top left dot x. Hold on. Let is vertical. This is gonna be a disaster when I need to do like turned rectangles and stuff, rotated rectangles. It's gonna have to start like this. What do I want to call this? I want to call this wall type. Horizontal, vertical. Selected. Is that how enums look? Is that how enums over here? No enums here. Yeah, that's cool. Okay, horizontal, vertical, slanted. I can already tell that I'm not going to get to the language at this point, but it is good to think ahead of this language. It is good to think ahead of what I'm going to need for this language when I'm working on this stuff, right? Man, it has been a long day, I tell you what. Work has been crazy. Feeling very tired, so my coding skills are probably not going to be the best right now. I can already see some typos I made above. But hopefully this won't be too bad. So if top left dot x equal to top bottom left, bottom right dot x return. So if the x's are equal, the y's are different. It's a vertical. top left dot x dot y is equal to bottom right dot y. Return wall type horizontal. Wall type slanted. Let's see how far I got. Not very far. Well, actually, it's not so bad, I guess. I don't need that right now. But yeah, it's just saying this A and B doesn't even work. So, match WT. So WT, if it is a wall type horizontal, I need to do some stuff. Wall type vertical, I need to do some stuff. Wall type slanted. I don't know. Throw an error. Right. What would it even be? I don't even know. It's called self. Top left. Does a vec2. Is it like vec2 new? How do I do that? Vec2 new. New 0.0, 0.0. And dimensions, also a vec2. New 0.0, 0.0. Length. Vec 0.0. Wall type. Just call it wall type slanted. A horizontal. Horizontal. A vertical. Okay, so if it is a horizontal wall, then my top left so wall width, should I do like half wall width? This is funny. This is hilarious. And I'm sorry, but half wall width. That is very funny. Also named like that. Width. Okay. So that means that my top left, I need to increase the Y value by half wall width. The x value is correct, but the y value needs to go up a little bit. Do I need a length? I'll figure out if I need a length. Man, I'm tired. Okay. I guess it's easy to have. If I have it now, then like I have it. I don't need to worry about calculating it later, which is always better. Pre-calculating values. Pre-calculating values is going to speed me up when I'm actually running my program, which is going to be important when I'm running, trying to do 1,000 putts at once. So, self, top left, that is equal to, I should underscore these. Top left, which is just that one, I guess. Top left is going to be equal to vec2 new. The x is correct. That x. And then the y needs to be increased. Plus half wall width. Which in this case is, I'll call it thickness. So that's top left. Dimensions, select 2, new. So we need the width and the height. Since it's a horizontal one, the width is going to be long. That's going to be excuse me, sorry. The width is going to be long. So that is going to be the top, bottom, right, dot x minus top left dot x. And then the height is going to be half wall thickness plus half wall thickness. Yes. And the length is going to be the width in this case. Can I do that? Can I like self-reference? We'll see. I'm gonna make sure this compiles, so put that in there. That's going to be wall type equal to horizontal. And that's going to be important for collisions, which way we bounce. Okay. F32? It's F32? I thought it was 64. That's probably gonna, that's gonna mess me up. Not at 32, okay. So maybe I can. Can I do self that? Can I self-reference like that in the constructor? I can't. Which that's fine. I'll just recalculate this, which is not a problem. Expected F64, found F32. Right. Okay, good to go. And then here, this is going to be very similar for the vertical wall. But instead, the x is going to need to be, we need to subtract the half wall thickness from the x. Because I need to move it to the left. I either need to move... No, it's still subtracted. Because it's like up, right? Because it's kind of reversed. So like down is positive, up is negative, so I need to subtract it from the y. And then the x, I need to subtract it from the x to kind of move the point to the left. And then the top left y, that's correct. And then dimensions, it's width, which the width here will just be this. And then the height is going to be the bottom right y minus the bottom right, or top left y. That's y, that's y. It's going to get kind of crazy for this, but we'll see when that gets to it. Okay, so let's create one. Wall new, back to new. Let's make it at, I don't know, where's my ball at? 300, 100. Do it at 200.0. 200.0. Back to new. Actually, no, I want to put it at 400. I want to put it closer to the ball than the wall is. To new, and the length. Do we even use? It's like I don't even use it. These are 2 points. So, put 200.0. And then I'm going to put the, actually no, put this as 400.0, 400.0. Okay. So now for every wall in walls, for W, let's call it W. I probably messed that up. Diameter. Walls diameter. Draw a rectangle. It's going to be W dot top left dot X, W dot top left dot Y, W dot dimensions dot X, W dot dimensions dot Y, and then brown. I wrote a lot of code. Let mute? True. Okay, yeah, I wrote a lot of code. Let's see if it even, Is it happier? Convert the identifier to upper camel case. Okay. Wall type, case sensitive, place it with wall type. That's what you do around here. I will do that around here. And then it's just mad about those two, which is cool because we're going to use them later. We don't need them right now, though. Let's draw a rectangle. It's brown. See if it looks like anything that I'm expecting. Yeah. That's actually exactly what I was hoping it would be. Just gonna go straight through it, right? Cool. We're on the road. We are on the road. Actually, let's do that again. Did it say create a horizontal wall? Perfect. Okay. So we have that working. We have that going. Is there like a dark brown? Dark gray, dark green. I like that look better. Okay, so it's dark brown. Excuse me. We have our walls being shown. Let's do some colliding. Move ball and collide. Right? So it's moving and we have to collide. This needs to be within the move function. Reset. Oh, that looks bad. Self.stop. Okay. Move ball and collide. And use a reference to a vector of walls. So walls is a reference to vector of walls. I don't want to print that every time. I think that's fine. We know when we're moving. Walls not found in the scope. Use create wall. Could not compile. Expected reference found struct. Let's give it a reference. That's correct. It is mad. I'm doing. I'm expecting that. Okay. So when we're moving and we're colliding, we have to figure out if we have collided or are going to collide with the wall. How do we know whether we're going to collide with a wall? Well, who needs to know that? Who needs to know if we're going to collide with the wall? Is that going to be the ball, or does the wall need to know? Where do we put this piece of code? Obviously, we put it in move ball and collide, but let's make I need a variable here because this is going to be updated in the collision code. So instead of moving by self velocity, it's going to be moving by the step. Back to new x L.y. So there's going to be step and step. Right. This is where it gets difficult. This is where it gets very difficult. Because we need to know, it might be too tired for me. I might be too tired to do this. Just heard me talk. It might be too tired for me. I might be too tired to do this right now. Take this back. This code looks so nice. It's gonna be destroyed. So here's what I think I need to do. I need to do what do I need to do? Wall collisions. If you're closer to the wall than our radius, flip the sign of our velocity based on the wall type. Right. Vertical. Flip X. Horizontal is flip Y. Slanted is some weird cosine or sine or tan. We'll figure that out when we get to it. But let's just do this right now. If we're closer to the wall than our radius. So what we need is distance to wall. This is going to be very buggy, actually. We need distance to wall. So for W in walls dot iter, if do that distance to wall, self dot pause, it's less than self dot radius. Here we go. Match on W dot wall type. In the case that the wall type is horizontal, we'll do some, not returning there. And I do this for every wall that'll move within bounds. Yeah, that makes sense. Horizontal. Go here. Wall type vertical. I do this. Wall type slanted. I do this. This is just going to be print line. Collided with slanted wall. Let's pop those in. It's going to be horizontal. This is going to be vertical. Okay, so if we're close enough to bounce off, that's basically what that's saying. And how do we find the distance to the wall? wall dot distance to wall. Whatever, that's a fine name. That doesn't matter. Call it's P, point P. This is a vec2. This turns into F32. Not an F2, that's crazy. F32. I don't even know if F2 is possible. It really shouldn't be. So how do I get... I was looking this up the other day because I knew that I was going to need this. Distance to line, which is the perpendicular distance. Distance from a point to a line. Perpendicular distance from point to a line. So what I have, I'm an equation, 2 points. The distance from the line is this. So, okay, so I have 2 points. So I do need to save off these 2 points in the wall. Okay, and I'll call it gonna be private. Private. A is a vec2, B also vec2. So I have A and B. Well, if we can imagine a line with 0 width, and that's not true actually. I have half wall thickness, so I can use half wall thickness, which is great. I'll type, I need A, top left, B, bottom right. Okay, distance to wall. So let's look at what this is. This is length. So divided by length. Absolute value of y2 minus y1. Okay, I mean, let's just pop these numbers in, I guess. y2 minus y1. Sure. Distance to wall, y2 minus y1. What, do I want to call these something? Or do I want to like... I'll call it like A. Hold on. I think I can just call this self. I don't need to make any adjustments or anything. And self reference. Let A equal y2 minus y1 times x. So it's self dot bottom right dot y minus self dot top left dot y times p dot, what was it, x. Oh, excuse me. No, that was right. Why is it x not y not? I don't know, whatever. Okay. Let b equals self dot bottom right dot x minus self dot bottom, ooh, getting tired, x times, it's a p dot y, p dot y, p dot y, do let C equal x2, y1. Okay. Self left bottom right. X times self that top left that y. X2, y1. X2, y1. Let D equal self that bottom right that y self that top left that x. The numerator equal the absolute value. Oh no. Of A minus B plus C minus D. And then I need to return. I guess I'm not going to use the word return. You don't do that in Rust for whatever reason. That divided by how big? Numerator divided by self dot length. And then it would be minus half wall thickness. Absolute value. I don't want a negative. That's crazy. Negative is fine, actually. I think I do want negative, because that tells me if I am inside the wall, which is bad. Unknown field. Oh, it's A and B. So bottom right is B. A. Let's add a link to this. I can like get references to this, can I? So don't forget where I got that from. Great wall type, really? And ball? I don't know about wall type and ball. Wait, hold on. Huh. Around here. I can't just do that. Can't. Oops. All right, I'm all good to go. I guess actually I do want to save this off because I want to print it. just do distance. There we go. Okay, let's see what happens. Probably something I'm not expecting. So if I move horizontally, should stay kind of the same. This looks correct. Okay, so the distance is working, but the collision is not doing anything. It's because they didn't tell it to do anything. So if we collided with the horizontal wall, let's see if it ever does collide. Yeah, collide. It's colliding. I don't like this printing out so much. Stop water direction. I don't want that to print out so much. See, here we go. It needs to be like within the bounds. Because it's saying it's colliding when it's way off the map, just because it crosses that axis. So yeah, it kind of needs to be like within its box to even count. So here's this check right here. If p dot x greater than self dot b dot x, because that's the right. It'll always be the right. Well, hold on a sec. Maybe looking for like an if let. That's not what I'm looking for. I'm looking for like bounds checking. Well, I guess that's literally what I want. If inbounds. Is that a word? I don't know. Equals match self dot wall type. It's horizontal. Wall type. Vertical. type slanted. This one's just going to be false. It's just going to be false. So here, what does it need to be if it's horizontal? The y needs to be within the bounds. That's it. Just the y needs to be within the bounds. Oh my god. So what this is p dot y would be greater than or less than self dot a dot y, and p dot x is less than, sorry, y is less than, greater than self dot b dot y. That should be vertical, I think. That should be vertical. Then here, what, p dot x less than self dot a dot x, and p dot y is greater than self dot b dot x. What's the rust not? Exclamation point. Okay. Not in bounds. Return float max. What's float max? Deprecated. Use F32 max. Okay. This can be cleaner. This can be a lot cleaner. I might come back to that. Thinking probably not. I shouldn't be colliding here. Should not be colliding. Should not be colliding when I'm way over here. So horizontal wall cares about the x. Yeah. Beta x has to be greater than, has to be less than, has to be greater than and then less than. I'll go by pattern. I don't want to confuse myself. It's still colliding. Still colliding right there, which it should not be. I think this works. It's getting ugly. It's what's so pretty. It's getting ugly. I don't want to go for a whole lot longer. I'll try to get this like simple case done, and then I think I'll wrap it up for the day. So let's talk this through. I messed that up. I'll try to run it again. So if I hit it over here, it's not colliding in that direction, it's not colliding in that direction, but if I go inside, it's colliding. Cool, that looks good to me. Collide over the horizontal wall, I want to flip the y. self dot L dot y is equal to negative self dot L dot y. That's my issue. When I'm going too fast, I'll just shoot through it, right? Gotta be going pretty fast. There we go. But we have that going. Let's try to pop open a vertical wall. See if we can make sure that's working too. What makes a vertical wall? If I just change the y instead of the x, right? So I can do 200, 400. I'll do 200, 200. And then instead of, it needs to be 200, 400. That's changing one, that changes one, that changes one. All right, I think that's right. Yeah, I think that's right. Let's check it out. That sure is a wall. I never made it do anything. Now, why is that wrong? Am I even checking against this wall? I should be. Yeah, that's fine. Let's see, if I remove, let's get rid of this wall. And let's print out the distance. This could be a whole slew of things, right? This could be that I'm just not even creating the wall correctly. I mean, just looking at it right now, I think I am. Sorry, I shouldn't care, but then when I get up here, I should care. Looks like I'm not even caring. So it's vertical wall. The y has to be greater than the top. Yep, and the y has to be less than the bottom. That looks correct to me. Let's debug some stuff. B dot y. I'm gonna do A dot y. Then I'm gonna do B dot y. That's all of them. B dot y, A dot y, slef, B dot y. What's going on here? Did I flip these? No, this is top left. This is top and this is bottom. Yeah, it gets stuck. So I'm going to need some kind of push mechanic. Right here to do. Stuck in a wall. Push it out. Okay, that's looking pretty good though. Let's get rid of this print. Get rid of that one as well. This is looking cool. I think this looks very cool. Very good start. Very good progress today. Took me longer than I expected, but that's, you know, that's life when you're working on software. Look at that double bounce, boom, boom. The same hit double bounce, that was too fast. Yeah, you can bounce right in the corner. It's dope. Okay. That's exactly what I want. So another thing I gotta worry about is to do stuck in wall, push it out. Yeah, and here's what I gotta do. We're doing one giant step. Need to break into quarter steps. Also, we phase through walls. Right? Right. Of course you can. So, that's a pretty good stopping point today. Let's push this up. I say simple collisions because obviously there's a couple to-dos. They're not that good. I mean, they're fine, but issues definitely we need to work out. So we finished walls and simple collisions. Feels good. Tomorrow, I'll say next time. It's not gonna be tomorrow. Maybe it'll be tomorrow. Next time, we'll write a language to create these screens. It's gonna be like passing a file for us to read, and this will create a hole called screens. Right? That's RLA, that is. Hole placement, ball placement, walls, etc. Kind of just hole, ball, wall. That's it. Yeah, this is it's been a fun project so far. and I think it's going to continue being a fun project. Let's just keep working at it. More things to do. Really cool things coming up in the near future. Once we could create these holes using a language that we can pass in, we're going to have a lot of fun with this, and I'll show you how. But until then, stay tuned.